Well, in this video I'll start with the question number 11 and try to complete the exercise. And here 11th question is very easy. It was in line with all which we have done so far. We have to prove triangle ABD is similar to triangle ECF, and in EBD we have at D right angle. Since it is right angle, the other side also will be right angle. Here also the same way, ECF we have a right angle, so one right angle is equal. We'll have to just show the other other thing and to prove that it is a similar triangle. So first give angle, that is angle in triangle ABD, angle ADB, that is ADB is equal to, this total angle will be 180 degrees minus this side angle, that is angle ADC, that is 180 minus 90, so 90 degrees. So angle ADB is equal to 90 degrees. We know this. First we have done this and we have kept it aside. Now we have proved ADB is 90 degrees, and now in ECF, that is this triangle ECF, F is 90 degrees, we know that. So let's write that angle EFC is equal to 90 degrees. So here this is given. Okay, since EF is perpendicular to AC, you can write, since EF is perpendicular to AC, EFC is equal to 90 degrees. Similarly, AD perpendicular to BC, directly we can write ADB is 90 degrees. So we need not move here and there. You can even need not do the previous thing. Directly you can write it. So here in these two triangles, first triangle we have an equal angle, that is ADB is equal to EFC, that is first angle we got it. So first generally we try AA, so we need to find another angle. For that, what is the clue given here? AB is equal to AC. So when two sides are equal, the angles opposite to these sides are equal. Given AB is equal to AC, which implies angle B is equal to angle C. So in this triangle we have angle B, in this triangle we have angle B is equal to, in this triangle we have angle C. So this is another A. So by AA criteria, these two triangles are similar. We can prove like that. Now coming to the next question. Now coming to the 12th question. Sides AB and BC and median AD of this triangle, and sides these two and median of this triangle are proportional. So let's write that side AB and side PQ, side BC and side QR, and median AD and median PM. So based on this, what we can say, first we need to show this. Okay, that is a different thing. If we need to show that, see, generally this is median sum. Median based we have total 3 sums in this exercise, 12, 14 and last one. So let's before solving this, let's what is given, that based on that what we can write, let us see. So AB, BC, AD, AB, BC and AD, and PQ, QR and PM. Okay, now another clue is given, that it is a median. Median means a line drawn from a point to the midpoint of opposite side. So this is midpoint. So let's write this again. AB by PQ is equal to BC by QR is equal to AD by PM. Now this fraction I want to multiply with half in the numerator and denominator. When you multiply numerator and denominator with same number, the value of fraction will not change. We know that. So we have multiplied with half in numerator and denominator. Why did we do this? Because half of AD is what? I'm sorry, we will not do it here. We will do it in this bigger side, that is BC, so that we will get half of BC BD, half of QR QM. So the same thing we will not do here, we will do here. Let's wait and do once again. So let's do it here, half of BC and half of QR. So what happens? Half of BC we got BD because D is midpoint since it's a median. Half of QR is QM. So let's write that again. AB by PQ is equal to half of BC. We can take BD. We can take DC also, but that is of no use for us. So we will take BD only. Similarly, QM is equal to AD by PM. Now if you observe these things, AB is proportional to PQ, BD is proportional to QM, and AD is proportional to PM. So these three sides of this triangle and three sides of this triangle are proportional. So what we can write is this first part. So just a moment. This first part is similar to this first part, that is triangle ABD is similar to triangle PQM. How can we say this? Because by SSS criteria here, which we have proved, all the three sides are proportional, so both are similar. So let's keep this result handy, and based on, since these two triangles are similar triangles, all the corresponding angles are equal. So this part is equal to this one is equal to this one. We are not interested in these two angles, but we are interested in this angle B is equal to angle Q, because this is a jewel we are waiting for. Once we get this clue, once we get this value, we can proceed with very easiest of the way. See now what is given. Let's see once. Now that we have this very important thing, our sum will complete in just one moment, because we know that AB is proportional to PQ, because it is given AB is proportional to PQ, and we know that BC is proportional to QR, that is also given. BC is proportional to QR, and now we have proved angle B is equal to angle Q, that is two sides are proportional and in between angle is equal. So by SAS these two triangles are similar. That is what we are asked to prove. So this is the proof. Since this is an easiest one, because here we got these two sides as proportional and these two sides as proportional. Next is a case where we get the other two sides where median is not there. In such case, simply by multiplying with half, we will not be able to getting the answer. So let's see that model also. This is very easiest of the three questions. Let's go to the other questions. So sides AB and AC and AD. So that let us write that AB, AC, AD are proportional to PQ, PR and PM. Same like in the previous case, they have given us these things. Now let's move this a little bit downwards so that it will be easy. Now so we already know there are two triangles, that is triangle ABC. So let's take A, B, C and P, Q, R. We also know that AD is a median, so let's take a median AD, C. Let's take a median AD, and let's take another median from P to Q. This time again we have to move a little. Okay, what is it given? PM. So let's mark the point PM. Now here if you see clearly, AB by PQ, AC by PR and AD by PM. Same like in the question number previous question that we have discussed, but here the difference is these two sides are there, these two sides are given. There if you see, these two sides are given as proportional. So it was very much easy. We did it in one step. Just we had to prove this angle B is equal to angle Q, and we got the answer. Here the thing is, we have got the other two sides, and now we are asked to prove that this ABC entire triangle is similar to triangle. So here again we have these two sides as proportional. All we need to do is we have to show the other side as proportional, or we have to show one angle in between them is proportional, equal. So let's see how we are going to do this. So here either we have two things, two sides are already we are showing the two, it is given that two sides are already proportional, only the other third side we have to or we have two sides are proportional, in between angle we can show equal, that is angle A is equal to angle P. If you can show, then also it will be sufficient. For this we will need to do a little bit of manipulation. Let's do that. So what we are going to do is this AD we are going to extend a little, and this PM also we are going to extend a little. Now how we are going to extend is not randomly. AD jitna hai AD, how much length we have AD, that much length we will bring it down, and such that, just a moment. So we have extended up to E such that, okay, E up to such that AD is equal to DE. AD जितना है DE उतना ही बनाया, PM जितना है MS उतना ही बनाया. Now प्रोड्यूस बोलो या एक्सटेंड बोलो, दोनों सेम ही है. नाउ इफ यू ऑब्जर्व, BD and DC are same and AD and DE are same. That means these two are diagonals for this quadrilateral and both are intersecting at the point D, which means that both the diagonals are bisecting. Here also both the diagonals are cutting equally. They are cutting each other into equal parts, which we call it as bisecting. And when the diagonals are bisecting, that quadrilateral must be minimum से minimum, it must be a parallelogram. It can be a rectangle also, but it depends upon whether your diagonals are equal or not. We don't know whether they both are equal or not. But for looking, since my pictures are like this, you might be feeling both are different, but they may be equal also or not also. So they both will be minimum से कम they are parallelogram, because the diagonals are bisecting. Last year we have read in the quadrilaterals lesson that if diagonals bisect, it must at least be a parallelogram. Since these two are parallelograms, what we can say now, we have got a very big advantage that this side is equal to this side and this side is equal to this. This is equal to, the opposite sides are equal. Now what is the big advantage you may call? Let us see what is given to us. We are given AB by PQ is equal to AC by PR is equal to AD by PM. This is what is given to us. Now let's do a small thing, that is, instead of AC, what can we take now? Let's change the color for proof's sake. AB by PQ, let's leave it this way, is equal to AC. In place of AC, what we can take? We can take BE, because opposite sides are equal. And in place of PR, we can take QS is equal to, in place of AD by PM, we will multiply it with 2 and 2. So 2 into AD by 2 into PM. What is 2 into AD? 2 into AD is AE by 2 into PM. PM का double क्या है? PS. So AB by PQ is equal to BE by QS is equal to AE by PS, means these three sides are proportional to these three sides. So by SSS we can write the triangle on this side, that is triangle ABE is similar to triangle PQS. So let's go to the next page. So what we have proved is that this triangle is similar to this triangle, that is, let's write that triangle AB is similar to triangle PQS. When this side triangles are similar, automatically the other side also same way we can prove. So let's write it directly. Similarly, triangle ACE is similar to triangle PRS. So why are we doing all these things? We are supposed to simply prove that ABC triangle is similar to PQR. And if you remember, in the very first thing, our target was to prove this angle A is equal to angle P. For that only we have been doing all this quadrilateral, and now we have finally come to a place where we can prove that, that is since AB is similar to PQS, we can write when similar the angles will be equal, that is this part of angle A is equal, that is this part we can write. Based on this result we can write BAE is equal to, here BAE के जगह पे क्या है, QPS. Similarly, here based on this result we write angle CAE is equal to RPS. Now if we add these two results, this one plus this one, what comes? BAE plus CAE. Let's see, BAE plus CAE. If you add those two, you will get directly the full angle A, that is angle BAC is equal to, if you add these two parts you get this full part, that is angle RPQ. Okay, so we have proved our target, that is angle A is equal to angle P. So we have got angle A is equal to angle P, and this side is proportional to this and this side is proportional to this, that is given. So by SSA, that is SAS by SAS, you can write both the triangle ABC is similar to triangle PQR. So this is how we have proved this median question, that is number 14. Now there is one more median question which is in reverse direction. Let us see what it is. So that is 16th question we are in. AD and PM are medians of triangles ABC and PQR respectively, where this thing. So here they have given it, triangle ABC is similar to triangle PQR. They have themselves given, this is ABC and this is PQR. They have given both are similar. Don't worry about proving both as similar. And they have said that PM is PM is a median and AD is a median, that also is given. Now they are asking us to prove just AB by PQ. Since ABC is similar to PQR, we can write AB by PQ is equal to BC by PR is equal to AC by PR. Sorry, BC by QR is equal to AC by, just a moment, we have taken the pictures in a different model. Let's see, no problem. So here the requirement is AB by PQ is, see, AB by PQ is equal to AD by PM. So when can we say that these two sides are proportional? Only when you take this triangle, that is PQM and ABD, and prove that both are yes similar. Now let's see, it is given that triangle ABC is equal to triangle PQR, similar to, is not equal to but is similar to triangle PQR. So now what we are interested in, AB PQ. So in place of AB we have PQ, so AB by PQ is equal to, and what is the side we are interested in, BC by QR. Now BC by QR, just we can multiply it with half and half, and what we get, half of BC BD and half of QR QM. So now AB by PQ is equal to BD by QM, that is these two sides are proportional. Only we have to check whether the in between angle is equal or not. Since these two triangles are similar, we can write angle B is equal to angle Q. दो ट्राइंगल अगर सिमिलर है तो उसका सभी एंगल्स करस्पॉन्डिंग एंगल्स इक्वल होंगे. तो इधर P के जगह पे इधर क्या है, Q है, सो एंगल B इज इक्वल टू एंगल Q. सो नाउ AB by PQ is equal to BD by QM. We have proved this too, and in between this angle also we have shown clear. So now this triangle is similar to this triangle. So what we have proved is, we have proved that triangle BD is similar to triangle PQM. So automatically you can write whatever is asked. Let us write this. AB by PQ is equal to AD by PM. That's the proof. That's it. So these are the three questions based on medians. One is the easiest one, the second one is a little bit lengthier. I don't say it is difficult, but it's lengthier. And third one is the reverse process, where in the first sum, if you remember, these two sides are given as proportional and asked us to, and these two sides are also given proportional. This is given, and these two sides are proportional given. They asked us to prove this one. Now in this last sum, they have given the reverse one and asking us to, they have directly given this and asking us to prove the reverse, whichever is. So if you observe these three sums, they are almost similar, except the second one, which is a little bit lengthier. So these three are important, and try practicing them well.